So this is question one of the 2016 AP Chemistry free response section. Again, I'm just giving you guidance. If you want to try to do this on your own, which I strongly suggest, I think that's great. And then you can look at the video if you hit a roadblock. Your choice. So they want to, the first question describes the dissolving of lithium chloride and sodium chloride. And then they take data, they give you data for the dissolving of lithium chloride. And they tell you the thermometer is good plus or minus zero point 0.1 grams, which means it goes out to the 10th place essentially, right? And then they say that the temperature of the solution, when you drop a certain amount of LiCl into the water, 10 grams in fact, the temperature changes this much. And then they say how much, and the first question is how much heat was absorbed by the solution, all right? So this is clearly, if they're asking about heat, they're asking about Q. If they got a change in temperature, they're clearly going to be using the Q equals MC delta T formula. Now, the critical thing is they're giving you the specific heat of the solution. By saying the word solution, that means you must use the mass of the solution. That's not the mass of the water. That's not the mass of the solid. That's the mass of both of them combined. You should figure out the delta T and be careful with sig figs. When you subtract, okay, if you get you should get either 2 or 3 sig figs in your temperature. When you're done, that should determine your sig figs of your final answer. Now, once you're done with figuring out the value for Q, that's A, right? You're going to have to figure out the delta H of solution. Now, remember, delta H is Q divided by the number of moles that, in this case, of lithium chloride dissolved. So you have to be careful. Are you using the whole solution? Are you just talking about the water? Or are you talking about the solute? Well, what they want you to know is how much energy in the first question, they're telling you how much energy is being absorbed by the water. The temperature of the water went up. So another thing that's important here is the sign of the delta H. So if you leave this without a sign, you're losing points, okay? If the temperature goes up in the water, that should tell you whether it's exothermic or endothermic, and you should use the appropriate delta H sign. If you want to figure out the numeric value for delta H, you're going to take the value of Q that you calculated in the first section, again, using the mass of the solution, not just the mass of water, okay, and put underneath that the number of moles that actually dissolved. All right, just be aware. Now, you don't have to put signs into your calculations, but if you're going to choose a sign at the end, you need to justify that with a short sentence as to why you're going to pick a negative or a positive value for a delta H in this particular example. Now, once you're done with that, you start getting into things that say ionic radius. And that immediately tells me that what's forthcoming now in the next part of this question is a question on lattice energy in all likelihood, because there's no other reason to bring up the radii of lithium versus sodium. So let's go to the next bunch of questions, or the next part of this question. So it says the first thing it says is write the complete electron configuration of a sodium ion in the ground state. And be careful, it's a cation. Remember, this is going to have lost its valence shell. So when you're doing this, right, and you're counting the number of electrons, don't include that extra electron. This is an Na+, and that means it's lost a particular number of electrons, and you should know what that is. Okay? The second thing, C says, using principles of atomic structure, explain why Na+ is larger than Li+. If you're going to justify this, you cannot say where it is on the periodic table. I was getting this in the tests, okay? I get this every single year. Yes, sodium is below lithium in the periodic table. And the reason it's there has to do with its electron configuration. So if they say atomic structure and they're talking about radius, if they're in the same family, right? Draw out the electron configurations, compare them, talk about the number of shells or energy levels or something like that. If you think nuclear charge is the more important variable in a con, you could do that too. But that would not be the right way to go with this, because nuclear charge is how you describe things that are either compare things that are isoelectronic or they're in the same row. And it says, which has the greater lattice enthalpy? So they're talking about lattice energy. They're calling it lattice enthalpy. That means how much energy is released during the formation of the lattice, right? Which one's more stable? If you're going to talk about this and you have to justify your answer, you want to talk about the charges and the radii. If one of them is the same, you want to mention that in your answer, not just mention the thing that's different, okay? Because there's two variables here in lattice energy. There's the charge difference, and there's the distance between the adjacent nuclei in the crystal lattice, okay? If one of those is the same, you need to mention it, because if it's not the same, it would be important. So you need to mention both variables in the equation if you want to get full credit on this. Below is a representation of the portion of lithium chloride. Identify the ions in the representation by writing appropriate form. Look, you should be able to figure out which one's the big one and which one's the small one. Okay, that's what they're getting at here, obviously. Either lithium is the smaller of the two or chloride's the smaller of the two. If you have your periodic table in front of you, if you haven't memorized it by now, you ought to right off the bat be able to say which is the larger of those two ions. Okay, and they're not even asking you to justify in this case, so you can just write in lithium for one and chloride for the other. All right. Letter F states that the enthalpy for lithium chloride is positive, indicating that it takes energy to break apart the ions of lithium chloride. However, the dissolution of lithium chloride in water is an exothermic process. All right, I don't want to explain this because it takes a lot of time. If you can't do this question, I strongly suggest you go back and watch the video I did in the most recent section on solution formation. Remember, there's 3 delta H's that go into solution formation. Okay? There's these, right? So I just really quick, this delta H, I'm sorry, I have to draw again. My pencil is not doing good here. Undo. Sorry, my Apple Pencil stopped working for a second. So there's 3 delta H's here. There's delta H1, which is separating out the solute particles, and that's always got a positive delta H. There's delta H2, which is separating the solute particle, that's also positive, and there's delta H3, which is the formation of the solution, which is always a negative value. All right. Discuss what those are if you're going to give a good answer to this question. Again, I suggest you check out the video. You can read about it in the textbook. There is a small section on solution formation.